Hi guys, welcome back to my channel Pirai. In this video, we are going to see about a Leetcode question number 633, sum of square numbers. So given a non-negative integer c, decide whether there are two integers a and b such that a square plus b square is equal to c. Okay, so for example, if they have given in the example like c is equal to 5, then I can tell you that 1 square plus 2 square is equal to 5. Right? So I can have two integers which sum of their square numbers will be equal to the given c. So I will be returning true. Okay. If it is c is equal to 3, then we can only take what? 1 square. Okay. And again I will be taking 1 square, then which is equal to 2. Or I can take 1 square plus 2 square, which is equal to 5. So I cannot yield this 3, right? So in this case, I will be returning false. That's it. Fine. So let us see the logic behind it. So what is the brute force approach that immediately comes into my mind? So the brute force approach that immediately comes into my mind is just take a loop and traverse from 0 up to the square root of the given c. Okay, again take another loop and traverse from 0 up to the square root of c and check whether for example it is a and it is b. Check whether if a square plus b square is equal to c, then I will be returning true. Else, after finishing this entire two loops, then I will be returning what? False. You can understand this, right? So this is the simple brute force approach, but unfortunately, this brute force approach will be of O of this c. Okay, because this will be running for square root of c into here also it will be running for square root of c, which is equal to what? Which is equal to c. Okay, so what is the time complexity? It is O of c or O of n, the given input. Okay, and what is the space complexity? Space complexity will be O of 1 because we haven't used any auxiliary space. Okay, fine. Whether we can still optimize it, because here it is somewhat optimized, but we may still optimize it, right? So how we are going to do that? So see here, I can tell you that this second for loop is unnecessary, right? The second for loop is unnecessary because you already gone with all the values from 0 to root of c. Then from there itself, you can check whether any other value will be yielding it or not, right? So for example, if it is c is equal to 5, okay? In this scenario, where should I traverse from 0, 1 and 2, right? Because what is square root of c? Square root of c is 2 point something value, right? Ignore these points values, only take the whole number. So it is 2. So I will be traversing 0, 1 and 2. Can you understand this? Yes. Now, what I am going to do is, first of all, I will be taking this 0. Now, I will be taking this 0 and subtracting from 5. So 5 minus 0 into 0, because 0 square, right? Instead, I will be writing like this, 0 square, which is equal to 5. Now I'll be taking a square root of this 5, and checking whether it is a whole value or not. But unfortunately, it is something like 2 point something value. Can you understand this? Yes. So what I am doing here is I'll be doing I am putting a minus symbol. Like, see here, what is a given condition we want to follow? It is a square plus b square, which is equal to c. Instead, I'm just following like c minus a square, which is equal to b square. So if I take this b square there, then it will be like b is equal to square root of c minus a square. If the outcoming value of this expression is a valid integer, it is an integer. If it is an integer, then I can return true. Else, I'll be just going to the next iteration. Can you understand this? Yes, that's the reason why here I'm doing what? 5 minus 0 square and taking a whole root of it. So which is equal to some float value. So it is not the answer we got. Okay. So go to the next value. It is 1. So 5 minus 1 square. Okay. Which is equal to, now here it's I'm putting the square root. Okay. Which is equal to square root of 4. Square root of 4 is equal to 2. Exactly it is what? It is integer, right? It is integer. So at this particular point, what I can tell you that if I take this 1, okay, and this 2, then squaring these and making the sum will leads to the what? Leads to the answer. See here, 1 square plus 2 square which is equal to 1 plus 4 which is equal to 5. 5 is the required answer. Can you understand this? So the simple trick is you want to understand this formula. That's it. Okay, b is equal to root of c minus a square. So by doing this, I can just finish this in only one loop. So I can tell you the time complexity will be over root of c. That's it. Yes. Okay. Also we have a second approach. It is like a two-pointer approach. Okay. Now we have done with the mapped approach. This approach. Now let us go with the two-pointer approach. It also yields the time complexity of over square root of c, but still you want to know as much as approaches, so that when you are going for a real-time interview, that you can tell these much of approaches, right? So now let us go with the two-pointer approach. So see here, let us take c is equal to 5. Okay, now what are all the elements I can take as a for like what is the condition? This c is equal to a square plus b square, right? If this condition satisfied, then I will be just returning true. So what are all the values of a I can take? 0, 1 and 2. Why? What is the square root of this 5? It will be 2 point something value. So take only of 0, 1 and 2. Now for b also we can take only 0, 1 and 2. So from this I can tell you that always the range will be between what? 0, 1 and 2 for a and b. Okay. So now what I'm going to do is I'll be taking these ranges like 0, 1 and 2. Initially I'll be pointing a pointer here. Okay, a left pointer, and here comes a right pointer. Okay. Now what I'm going to supposed to do is I want to find whether these 2 points makes my value. Okay, which means see here, 0 square plus 2 square which is equal to what? Which is equal to 4. Whether 4 is equal to 5? No. Whether 4 is greater than 5? No. Whether 4 is less than 5? Yes, 4 is less than 5, which means what it is telling me? Hey, you want to go to the greater value. Greater value means I will be shifting my L pointer to +1. Can you understand this? 2 is next in this. Now again check whether 1 square plus 2 square is equal to what? 5. So 5 is equal to 5. So here itself I will be returning what? True. Okay. In some other cases, like for example, the value that came here is larger. So value came here is larger than the target value. Okay. In that particular scenario, I'll be doing R minus minus. Can you understand this? Whenever our value is lesser than the target value, we will be incrementing our left pointer so that I'll be getting the incrementation value. Okay. Whenever the target is smaller, then I want to decrement the value. So I will be making my R minus minus. By doing this, I can tell you that my time complexity will be over, square root of c, and space complexity will be over 1. Fine. Now let us see the code for this so that you can understand this clearly. See here, it is a Java code. If you want Python or C++ code, you can check in the description. Okay. Fine. So see here, this is going to the first approach. I will be taking I is equal to 0 and I star I is lesser than or equal to c, which means I want to go up to what? Up to the square root of c, and I'll be doing a incrementation of I. Now b2 is equal to c minus, okay, which means b square is equal to c minus I star I. Can you understand this? This is what we have done there also. If I move the b square that side, then it will be c minus a square. Here instead of a, I have written like I. Okay. Now what is the value of b? Value of b will be converting the square root of b2 into the integer value and checking whether b star b is equal to b2. Can you understand this? By using this, we can say whether these two are same or not. If it is integer, then these two will be same. For example, if it is like 2, okay, then 2 into 2 which is equal to 4, but it is something like 2 point something value, then that point value will be neglected, right? So now it will be 4, but actual value will be 5. Can you understand this, what I am doing here? Okay. So in this particular scenario, I will be returning true. After finishing this entire loop, I didn't got the value, then I will be returning false. Okay. So it is a simple code. Fine. So let me just comment this out. So this is going to be your first approach. What is your second approach is, I have done with the 2-pointer approach, right? In this 2-pointer approach, I'll be taking a left pointer to 0 and right pointer to the math dot square root of c. As you know, the range will be between what? 0 up to the square root of c. Okay. And also we are not going to take the point value. That's the reason why I'm just typecasting to the long value. Okay. Because see here, they have given what? The range will be from 0 to 2 power 31 minus 1. That's the reason why I'm taking that as a long value. Now, while my left pointer is always less than or equal to the right pointer, then only I can tell you that we can go and proceed. Whenever, see here, whenever, like we are having like this, okay, and here is my left pointer, meanwhile here is my right pointer, which means right pointer is lesser than the left pointer. Whenever my 2 pointers are overcrossing like this, then I'll be just terminating the loop and returning false. Can you understand this? If you already go with my 2-pointer approach and the binary search video, 2-pointer and binary search video, you can understand this clearly. Okay, fine. So let us continue here. Now, what is the sum? Sum is equal to my left star left plus right star right. So I am doing a C is equal to a square plus b square. For that, I have made ready of a square and b square. Now I am just checking whether these two are equal. Okay. If sum and the c value are equal, then I will be returning true. If sum is greater than c, then I want to lower the value. So for that, I will be making my right pointer to go towards the left one time. Okay, which means right minus minus. Else I want to do incrementation value. So I will be doing left plus plus. Okay. Now after finishing this entire loop got terminated. After I will be returning false. Okay. Let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. If you have any doubts in this video, you can just comment it out. I will be commenting it out the answer. Thank you.